Algebra 2 students, we are going to review graphing linear functions. I say review, and if it's not review, please talk to your teacher because I'm assuming you've studied graphing linear functions. It's important to remember that a function in mathematics is anything that relates two variables. Traditionally, that relation, and it's a type of relation that's very specific. The relation that we're talking about is generally a y variable defined by some function of x. This is a notation saying that there's some function happening to x. It could be as simple as y equals x. That is a function. It maps every x value to the y value. Functions have to be specific in the sense that x can only go to one y value. So you can never have something like this be a function because in the xy plane there would be an x value that goes to two different y values. So when we say function, one way to know it's a function is it passes what's called the vertical line test. No function can have a vertical line hit it in two places. It can only touch it in one place. So this would be a function. Again, a vertical line would only hit it in one place. Let's look at the word linear, and when we talk about linear, we're only talking about functions whose graph are a straight line. So you've got the xy plane, here's a linear function, here's a linear function, there's a linear function, everywhere a linear function. If we have a vertical line, however, we would not consider that to be a linear function because it's not a function at all. It fails the vertical line test. So linear functions, we're just going to review how do we graph them, how do we spot them, all that good stuff. To be fully mathematical here, I would define a linear function the following way. I would say a linear function is any polynomial function where the degree of x, or the highest degree, is 1, with the degree of 1. Now, polynomial is a fancy way of saying a bunch of stuff written out with algebraic terms with no x's in the denominators. So 3x to the fourth minus 2x squared plus 5x minus 1. That's a polynomial. If I say y equals that, that's a polynomial function. The degree is the highest exponent. In this case, it's a 4. So this is not a linear function. A linear function is going to look something like this. Y equals mx plus b. I use the letter m because we give credit to the French mathematician who first studied linear functions. And the word in French, monter, means to climb. So an English speaker might talk about the slope of a line. A French mathematician hundreds of years ago talked about the way a line climbed, and he talked about that climbing using his language. So he used the verb monter, and that's where we get m for slope. Now b, I'm not sure why we use b for the y-intercept, but we do. So this is a linear function. It's got a y, it's got an x. The highest exponent on x is a 1. Because it's a 1, we don't write it. It's got a number in front of x. It's got a y-intercept. And let's just review all these things. So slope. Slope is often called a change in y over change in x, a rise over a run. Change in y over change in x. The rise of a line divided by the run of a line. You can find the slope of any linear function if you know 2 points on the linear function, x1, comma y1, and x2, comma y2. The slope would be found by taking y2 minus y1 and then taking x2 minus x1, the change in the y coordinates over the change in the x coordinates. You could do y1 minus y2 divided by x1 minus x2. The order doesn't matter as long as the first y coordinate corresponds to the first x coordinate and the second y coordinate corresponds to the second x coordinate. So you cannot do y2 minus y1 over x1 minus x2. Can't do that. So that's slope. often called the letter M. It describes how a line climbs. Positive lines go up from left to right. Positive slopes go up from left to right. Negative slopes go down from left to right. If we look at a horizontal line, it has a zero run and a zero rise and a run. So that's 0 over a number, and that's equal to 0. If we look at vertical lines, ooh, that is not a good vertical line. If we look at vertical lines, it has a rise but no run. A rise over 0, that would be undefined. Makes sense because it's not a function, undefined slope. Another important aspect of a linear function is the x and y intercepts. Now the y-intercept is usually a little bit easier to find and it helps with graphing. The x-intercept you have to do a little algebra. So here's x, here's y. If I draw any line, maybe one right here, if I draw another line, we'll use a different color. How about this one here? And if I draw another line and we'll use a different color, how about this one down here? All three of these lines have a y-intercept, a point that crosses the y-axis, a point where x is equal to 0. If you look at this line here in gold, the y-intercept is right there. It's a positive number. If you look at the line in black, the y-intercept is right there. It's a negative number. And if you look at the line in blue, the y-intercept is also a negative number, and it's more negative than the line in black. It's easy on a linear function, if you know y equals mx plus b, to find the y-intercept. You just say x equals 0. You plug in 0 here. 0 times anything is 0. You get y equals 0 plus b, or b. This is the y-intercept, the value of y when x is 0. To find the x-intercept, and there's only two x-intercepts in these examples, there's one right here, and there's an x-intercept right here. Notice the black line I tried to draw in a way that was parallel to the x-axis, so it'll never cross that. All lines will have a y-intercept. Not every line will have a x-intercept. Most will. I am excluding vertical lines in this conversation. They have an x-intercept but no y-intercept. And I'm not really talking about them in this conversation because they're not functions. And I said I'm talking about linear functions. Anyway, quick review of how you use slope and y-intercept to graph. If I give you a function, a linear function, y equals 2/3 x minus 5. You plug in x equals 0, you get -5. That means you have a y-intercept of -5. From there, you can use the slope written as a fraction to help you graph. I intentionally picked 2/3 so there's a numerator and a denominator. If I told you the slope was 2, I want you to think about it as 2 over 1. If I told you the slope was -5, I want you to think about it as -5 over 1. If I told you the slope was -7/8, then it's -7 over 8, or, that's a fine way to think about it. Use the slope 2/3 to find your next point from the y-intercept up to +2, and then over 1, 2, 3, over +3. That is what slope is. A change in y over change in x, how a line climbs. Always remember to label your axes. Up 2 over 3. If the slope was -7/8, you would go down 1, 2, 3, 4, 5, 6, 7. And then once you've gone down 7, you would go over in the positive direction 8. So 1, 2, 3, 4, 5, 6, 7, 8. You'd be all the way down here. And that line would look like this. And do you see how it's falling as you move from left to right? That would be a negative slope. If the slope was 0, it would be y equals 0 times x, which is 0 minus 5. You would just have this 0 slope of a horizontal line. Good? The last thing is there is x equals 5, or let's say x equals -3. That would be right here, 1, 2, 3. X is -3 there, it's -3 here, and it's -3 all along that horizontal line. The last thing I want to review, and I hope it's review, is another form of a line called point slope. Point slope is actually my favorite form of a line. It looks like this. If you know a slope m and you know a coordinate x1, y1, then you can write the equation of a line by taking y minus that y coordinate, and it equals the slope times x minus the x coordinate. I like this because all you need to write an equation of a line is a slope and a point. That's all you need. And I love the kind of game that it creates for a math teacher. Can you find a slope? Can you find a point? Can you find a slope? Can you find a point? So if I give you a point, here's a really easy example. It goes through the point -5, 4, and it has a slope of, I don't know, 3/7. Then the equation of this line is y minus the y coordinate equals the slope times x minus the x coordinate. X minus a -5 becomes x plus 5. Good? Now if you wanted to, you could distribute that, that 3/7, get y minus 4 equals 3/7 x plus 15/7. Then you could add 4 to both sides. Adding 4 is really adding 28/7. So now I get y equals 3/7 x plus 15 plus 28. What's that? 43/7. Good. The y-intercept of the line is 43/7. The slope is 3/7. That's going to make it easier to graph. Not nice numbers, but easier to graph. This is a great place to use your graphing calculator. If you want to just see the equation of the line, because sometimes it's hard to find 43/7 on a grid you draw by hand. The other thing I want to do, and then it'll be time to go, is I want to find the x-intercept. If the y-intercept is the value of y when x is 0, then it stands to reason that the x-intercept is the value of x when y is 0. So to find the x-intercept, replace y with 0. 0 equals 3/7 x plus 43/7. Now this is pretty easy. Clear the fraction, multiply everything by 7. 0 equals 3x plus 43. Subtract 43 from both sides, divide by 3. You get x equals -43/3. If I was to graph this line, and 43/7 is a little bit bigger than 6, so this is an approximation. 1, 2, 3, 4, 5, 6. I'm like a little bit above 6. I would go down 3, 1, 2, 3, and over 7. 1, 2, 3, 4, 5, 6, 7. That would be down 3 over 7. 1, 2, 3. Good, and then over 7. If I draw that line, this would hit at... Wait a minute, where's my... I made a mistake in my math, right? Oh, look what I did with my slope. I went down 3 and positive 7. So up 3, 1, 2, 3, and over 7. That would look way out here. So this x-intercept, and I'm sorry I'm going so fast here, I'm being sloppy, would be -43/3. So a couple things happened here I'm going to preserve in the video as opposed to turn off and re-record. I drew my line and I didn't know I was making a mistake until I said, well, here's the x-intercept, but wait, that's a positive number and I got it negative. Where's my mistake? I was pretty confident in my algebra here, and that allowed me to see my mistake of the slope. +3 to the right 7. Good. Now -43/3 is what? What is it, about 14 something? So this is not drawn to scale, but at least it gives you an idea that it would be on the correct side with this sketch. Alright, that was a pretty sloppy video there at the end. My goal is that this is mostly review. How do you graph lines? How do you find the y-intercept and x-intercept? And how do you use point-slope form? If these things aren't review, you need to let me or Miss Mingles know immediately. For an Algebra 2 student, this should be review of things you've learned. Alright, hope you're doing well. Have a good night. Peace.